All right, so today we have Devs United, JTTG, Team 300, and To the Moon. All right, so who wants to go first? Okay, and I will try to remember to um, uh, publish the survey. Okay, all right, which team wants to go first? You can share your screen.
Uh, we would like to go first if that's cool.
Okay, and your team is?
We are Devs United.
Okay, take it away. You have 15 minutes. Okay, show us what you got.
For sure. Okay, let me just share my screen.
Click here to share. I
Yeah.
see it. Okay.
Oh god, this is my video
There
and
you
I'll
are.
share the
We see you.
screen.
You're out in your backyard.
Yeah, it's a
Yeah.
it's a virtual background. I'm actually in a room with screen two. Hmm, wait, can everybody see the
Okay.
presentation?
Yeah. Why we chose CMM?
Okay, perfect. Great. Now, oh, that's okay. Okay, so we made a compiler in C++ for our C language. This is kind of the stuff we're going to cover in the presentation. We're going to talk about the language. We're going to show some samples, syntax programs. We're going to show the grammar file, and then Marco will show a demo of the language in action. So what is C or CMM, and why did we choose it? Well, CMM, it's called C it's a C-like language. So we basically, the CMM compiles in C++. CMM is strongly typed. We have int, we have string, we have char, we have all that. We want to do strongly typed so that it'll be easier for the compiler. Because a lot of like weakly typed languages have interpreters and all, and we're running a compiler. So, and CMM is inspired by both Pascal and C++, as you will see later in the sample programs. So why did we choose CMM? Well, see, we are all familiar with C, and it's one of the best languages to compile. And so a C-like language would be the easiest to work with in a compiler project because it's high level enough for us to write code in, but it's low level enough to easily compile. So instead of like Python or creating a completely different language, we decided to create a language that was close to C so that the compiling would be as convenient as possible. And now we're going to go through some sample programs and parse trees. So first we have the conditional statement, which is the if else and then the switch. So here's some sample if else statement code. As you can see, like Pascal, instead of program, we have project name, then int name, we have the variables, and we can assign them if something, then this, else, something else. Very similar to C. We have print line instead of like printf though, but it's a similar thing. We have print line I equals I, j equals j, so you can print multiple variables on one line. And this is a sample 6 statement code. We're testing each like case for while, so we have different code for each. And here you have void main, which is similar to C again. We switch beta to I, and then we have a character with an even, odd, prime initialized. Then we switched I plus 1. In this case, it would be 4, but like it could be. So we would get J is 574 times 3. So yeah, that's pretty much the conditional stuff for CMM. And now my other group mates can explain the rest. Oh yeah, and actually never mind. So test if, of course, needed to be like physically tested, which is where this parse tree came from. We took the project test if and pasted it into the program thing, and then we got this, and this success switch. And now it's time for my roommate to explain while and all.
Okay, so this is the parse tree for the while function. So for the while that we have written here, so an example here is, the while I equal to while I less than or equal to 5, which is in the void main section. So if you look to the main parse tree that we have here, we took a wide screenshot of everything, but this is in this current section, this is the parse tree for the first while loop that you see. So you can, it has a while, the expression, and then you can see as it goes down to I less than or equal to 5, and then you can see the println statement in the next to it. So in this parse tree, it gives like a proper progression of all the code for all the parse tree for while statements here. So yeah, this is the parse tree for the while, and an instance of how it was used in the test while function and how it shows up in the parse tree. Next slide. And here we have the do while. So for the do while, this do while work is for the first do while that you see here. It starts out with a do, and then it gives the println, which you can see, I guess halfway down there with println, and then write arguments where it has the I equal to, and then the comma, the I. So you can see the progression of this in the parse tree for the do while statement too. Yeah, next slide. Next slide. And similarly for the for loop, you can see the parse tree for the for loop here with for I equal to 1. It's the first for loop. So we just basically, out of the whole test file, we just took parse tree for a small section and displayed it here, for example, with the first for loop. And then, yeah, and then we just progressed from there. Next. Here, so for the Newton tree for basically the creation of a function, we here in the top left, you can see the code, which is double root and the parameters of double x. So you can see how it's built here in the parse tree with the type identifier of double, the routine identifier root, and then the parameters that go inside, and then you see the tree as it goes down to double x. And so that's like the function, I guess the creation declaration part here, and then we'll get to the declaration next. So next slide, please. So here, it's a bit congested, but on the left side, we see the function call from the previous slide for the code, where you'll see the function being called. Yes, so you see the for loop, and then the function being called on the left side, whereas on the right side, you see the return statement, where I think at the left, on the left side of the right picture, you should see a return R, which is how we want it, which is like the parse tree for the return statement. Yeah, next slide.
Okay, I will talk about the grammar files and syntax diagram. Next slide. The first is the data type and type checking. We support a few data types such as in Boolean, double, char, and string. You see the type check is handled in the type checker.cbb to ensure the data type is correct. And the predefined .cbb file gives the definition of each type. And the last one is the grammar G4 file has a reference to the type check class. So that's all. Next slide. For the operation and assignment statement, we support some basic operation for compare, add, subtract, and multiply. It's very similar to C language. And for assignment statement, the first in normal assignment left-hand side equal right-hand side. And we are adding increment and decrement assignment for I minus minus and I plus plus. Next slide. For conditional statement, we handle if and switch. For if statement, we are supporting if and optional else with true and false statement. And for switch, also similar to C, but without the break statement, it supports multiple case range for the same statement. Next slide. And here the loop statement for while, do while, and for. Look at on the for the for statement, we are adding for the for statement with the following syntax: precondition statement followed by an expression and post statement to the loop. Next slide. Okay, and the last one is function call and return. The function definition start with return type plus function name plus input parameters to execute a function. The syntax is function name followed by input arguments. We also add the return statement for the non-void function. It's come with the return keyword and an optional expression. And now we move on to the demo. Next slide.
All right, so I'll be demoing our compiler. The program I'm going to demo is Newton 3. That's the one that we're all familiar with. It has looping statements, conditionals, and function calls with return types. So it'll cover everything, all the functionalities of our compiler. So first, we'll compile the source program to make a .j file. There it is. So we can all see the assembly code that was generated. Now we'll make the .class file. And just to check, there it is. And then let's run it to get an output. So there's the output we get from the compiled program. And now if we want, we can test it by just running the CMM source program by itself. And you can see that they're the same. So that's it.
Very impressive. Very good. Any questions from the audience? So the CMM programs look very similar to the Pascal test programs. Did you translate them by hand?
Yes.
Oh, okay. I thought maybe you had used a converter to do that. Okay. Amazing. So you have a working compiler. Now, since you did CMM, I may want to point out that there is something called small c. Have you heard of that? SMALLC. If you Google that, you'll find that back when we all had microcomputers, there was a small version of C, which what you've done reminds me of very much of. So you may want to take a look at that, because that was kind of an industry standard language back then, and that there is documentation on it. So you can take a look and see how that compares with what you did. Okay. All right, excellent. Any questions from the audience? I did turn on the survey. Sorry, I didn't do that right at the beginning, but please remember to take the survey. Okay. All right, thank you very much. And then who wanted to go next? What was that? JTTG?
Yeah.
Yes.
Okay, all right, take it away. Okay.
Share. Okay. Can everyone see the screen?
The Go language. All right.
Yeah.
Yes. So we decided to go with a Go compiler for our project. My name's Hamska, and I'm working with Donnie, Cindy, and Wilson.
So our source language is based on Go, which is an open source programming language that's developed by Google. It's a functional language because while you can follow some OOP principles, not all OOP principles are supported by Go.
So for our implementation, we made a if-else control statements, while looping statements. We added the data types int, char, string, boolean, and float. And then we also have functions where you can pass arguments, and it can have a return type of void, or it can have a return type. And then we also have a main function, a print statement, and print with arguments.
And so this is parts of our grammar files, since we did edit a lot. These are just two examples of things that were modified. So for first, if we're looking at the if statement, we do have just the regular if for the true statement, and then an else statement. There is a second path, and we wanted to do an else if, but we're still working on implementing that. Similarly, with the while statement, we also just have while with the expression that you're validating for, and then the statement that you would want to execute inside that while statement. And then additionally, we also modified some of the operands and the relational operators. And you can see that at the bottom. And so this is one of our test programs, and we made this to test our if statements. So on the left, you can see our entire program that we wrote. And after you compile and run this, it will generate a parse tree. And then here I just screenshotted just a segment of the parse tree, focusing on the first if statement in our program, which is shown down here. So it's basically just if I is equal to j, then we set x equal to 3.14. If not, x would be set to -5. So in the first branch, you can see that's going on over here. I is equal to j, so it'll check here. If it's true, it'll go down this path where it'll set x to 3.14. If not, then it'll set it to -5. And then here's the Jasmine code that was generated for this program. On the left, you can see the entire thing. Again, I just wanted to show everyone just segments of it. So in the beginning, you can see all the variables being created. And then on the right side, you can just see basically the code itself. So like I mentioned earlier, if I is equal to j, and then it'll do either assignments.
Now I'll talk a bit about the while statement we implemented. So this main function is an example of how we call while loop in this program. So in this program, we set I to 1 and x to 1.1 initially, and we're going to keep looping until I reaches 10. And inside this while loop, we'll increment I by 1 each time and x by 0.1 each time. And then we'll print out the value of x in each loop. And down below, it's a screenshot of the output of this program. And in the right-hand side, it's the parse tree generated by this while loop. So you can see that the comparing condition of the while loop is when x is not equal to 10. And inside this while statement block, there's a compound statement that's going to increment the value of I, x, and also print out the value of x. Next slide. And here's the Jasmine code generated by this while loop. We can see that there's like some if comparing statements, and then some arithmetic operations to increment the value of I and x.
So this is another sample program where we're testing the functions and the inputs which are passed as arguments to the function and the return type of the function. So we have a add function, which is taking two integers, and then it'll return the value. So, and then in the main function, we're just doing some simple arithmetic operations and also the print statements. And so in the parse tree, you can see that at the top left that there's the j and then subtracting, I minus j, which is equal to k, and that was a print statement. And then in the bottom, we can also see the add function where we have the print adding and then the statement x plus y. Yeah, next slide. And then this is the Jasmine object code for this function. So on the left, we can see the add function where it will store the two variables that were passed into the function, and then it will calculate x plus y. And then on the right, we can see some of the Jasmine code that was generated for the print statement.
Okay, so I'll be doing the demo, so I'll share my screen. Okay, so the first Go file that I'd like to demo is this one. So this is a test function file, and this file will demonstrate like function definition and calling, print statements, function calls, and passing in parameters, assignment statements, and also basic arithmetic operations. So I'll go ahead and compile this with our project. Okay, so you can see that everything works properly, and also the Jasmine file was created. So I'll go ahead and run the Jasmine thing on it. You can see it prints everything correctly. So if we go back to the code, you see it wants to print main first, which it does, and then it calls add function, which prints adding, and then it prints the result of this operation, and then it prints the remaining like arithmetic operations. And the next file I'd like to demo is test if. So this file will demonstrate like the if else statements. So again, the Jasmine file is created properly. Whoops. And you can see it prints everything out correctly. And then the last file I'd like to demonstrate is test while, which will demonstrate the while statement. And you can see again, it prints everything out correctly. So if we go back to the code, it prints x, which is a float of 1.1, and every time it increments by 0.1. So it prints everything out correctly from 1.2 to 2.0. And that's all for the demo.
Very good. You have working code. Any questions from the audience?
I have one question, if that's okay.
Go ahead. Yeah.
Then doesn't Go have imports? We were doing GoTo and we were stuck with imports, so we asked a question, but that's why I'm just wondering if you guys handled imports or no.
We weren't able to do the imports, no.
Oh, okay, thank you.
Yeah, there was a question about imports, and often the imports bring in function headers so that you can call the functions properly. And also as a message to the linker that, hey, there's a library out there that we're going to be linking against. So if you're going to do a language with imports, you can kind of fake it by maybe writing a preprocessor that when there's an import, it actually copies in the function definitions. And then, of course, when it comes time to running your program, then you have to know to include the library when you run the program. So there are ways of kind of faking or simplifying how imports work. And so if you choose a language that does importing, then that's something you may want to consider doing. But that was kind of beyond what I had expected people to do. So that would definitely be an extra if you decide to write a preprocessor that handles imports. Any other questions or comments? Okay, well, I'm impressed that
Wait,
you have,
actually, I have a question.
yeah, go ahead.
So it's been a while since I did stuff in Go, but I remember one thing right now is that if you declare a variable and you don't use it, it'll throw you an error. Did you guys like implement that that aspect of Go or no?
We have to still work on the error checking. So yeah, that's something we'll consider doing.
All right, cool.
That wouldn't be hard to do. You just keep track in your symbol table whether or not a variable was ever used. Yeah. Any other comments or questions? Okay, well, thank you very much. Okay, Team 300. Okay, don't forget to do the survey for JTTG. I will now open up the survey for Team 300. Okay.
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 Oh, oops.
All right.
All right. Hi, we are Team 300. My name is Jason, and I'm with Victor, William, and Vivek. Our compiler project is Digital 300.
You have to speak a little bit louder, please.
Hello, can you hear me? Hello.
I can hear you.
All right.
Oh,
So like I said, our programming source language is Digital 300, D3 for short. Our language is a mixture of Verilog, assembly language, C++, and Pascal. For data types, we made three main predefined terms. Word, which is an alias for an integer and is 4 bytes. Byte for char, which is 1 byte, and float for real number. Next.
So for our basic statement grammar, we decided to use the semicolon to terminate statements, just like C and C++, because these were the first languages that we had learned. Additionally, we only have two statement types, assignment and compound. So for the assignment statement, we store the right-hand side to the left-hand side, as opposed to the traditional left-hand side is equal to the right-hand side. Then for the compound statement, it is the same as Pascal, as we thought this was a good design. Next slide. So next we have our conditional and loop statements. So we have 5 types: if, case, for, while, and repeat. The if statement is the same as traditional languages such as C++, but for our case statement, we took inspiration from Verilog and decided to use a multiplexer. So a traditional multiplexer takes in several inputs and produces a single output based on the select control that is given. And this is similar to case statements, as depending on the expression, we go to that corresponding block. Then with our for loop, we have loop counter, where we specify the start variable and the range from which it will iterate. And in each iteration, it will either perform an addition or a subtraction operation on that start variable. Then for our while and repeat statements, we have loop, if, and feedback respectively. Next slide. Then next we have the grammar for expressions. So for this, we took inspiration from assembly language, where you specify the operator you want and you list the operands. So add 1, 2 is the same as 1 plus 2. And so we have implemented the basic arithmetic operations, addition, subtraction, integer divide, float divide, multiplication, and or. Additionally, we have the basic relational operators as well, such as equals, not equals, less than or equals, greater than, and greater than or equals. And the precedence order is as follows. So we have division and multiplication as the highest. Then we have addition and subtraction next. And lastly, we have the relational operators as the lowest. Next slide. And then finally, here's just a table of all the operators we have, of course, with the corresponding syntax and their use cases. And next slide.
All right, so for the grammar, so I'll be talking about the class procedure function block. So a class is like equivalent to like Pascal program for the header. So we donate the class as system because like Verilog has like the whole entire system, and system will contain the identifier, actually the name of the system, and also the block. And block is like all the declaration and the compound statement inside. And you have to end it with the end system. Just like Verilog, you have to like start with the module, then at the end you have to write end module. Then in procedure function, these are servers. So in procedure, we take consideration for C++ syntax for templates. So in templates, to specify the data type, you put like a arrow between, and inside will be like the type you want. So in procedure, we put void, and the parameter that's like same syntax C++. You have the data type in the front, and in the right hand side will be just the identifier. And same for the function. The only difference that you have the type spec instead of the void. Then just like Pascal, our language also supports nested functions, as like you could have like a module within the system and also a submodule within a module. And we donate the two functions as a module, as you see from the table. Next slide. All right, so some interesting feature. So this is we're still working some add up. So it would be nice to have a single line multiple variable assignment stitch, as you see in the bone right there. So our syntax for that, you have to create like another offset rule for the assignment, which will have a store, and inside that you will have the parentheses, and inside it will be like a series of expression. And on the right hand side, you will have the series of variable, and each of them will like specify like which variable or which expression you want to assign to that respective variable. And the second thing will be like really interesting is a bit masking function. So a bit masking is when like you want to change a specific bit without changing the other bit in the register. So our planned masking function will have two parameters. One is the register, which is the word data type, 4-bit wide. And other one is the bit, which is the byte data type, to specify like, which bit you want to like change. And the return type will be just the word, like the result. And the bottom right here, you'll see like there's three sum of function that depend input, which is the set bit to set the bit to 1, and reset the bit to 0, and get bit is like an accessor to like get the bit at that specific bit position. Next slide. So this is our semicolon 1. So semicolon 1 covers the function and the loop counter, which is like a for loop. So in the so we have a system like I mentioned before, and inside you have the module inside the system, which is a function inside the class. So in the module, in the function, we have a get min that will get the minimum based on the 3 float parameters. Then after that, it will execute the loop counter, which will loop from A to Z, and each iteration will add up to 3. And the right hand side is the assembly code for that, for the for loop. So you can see that like the first thing it will do, it will at branch 7, it's gonna like check the expression to see like if it's like greater than the expression, which is Z. Then if it is, it's gonna push the constant 0 into the operand stack. Then otherwise it will push the 1 from label 9. Then under label 10, it will do the comparison saying that if it's not equal to 0, then if it is, then it will just branch to L8, which will exit the for loop. Otherwise, it will execute the block. And you can see like the last few lines in the block, it will do like a get static char C, and it will do the icons 3. It will push 2 operand stack, and it will add those together. And that's how like it managed to like increment that variable by 3 in the each iteration. Next slide. So this is like the parsed.
Oh, wait. Oh, sorry. I think I went to. Oh wait. Next slide or?
Yeah, I mean one slide before 2. Yeah. Oh yeah, and this is like the parse tree for the case. So case we use like a mux, and each mux have like each branch, and each branch is like a selector, like series of input. You can see right there. Next slide. I think it's before.
Skipped accidentally. This one or? Sorry.
Yes. Sorry about that. Yeah, that one is the sample program too. All right. So this is for 1. So 1, you have like a for loop. We have an assignment, right, and a for loop. And in the for loop, we start with the loop counter. And there are 3 fields, you can say 3 fields. One is like the start condition. Other one is like the end condition, and the last one is like the counter, like add or subtract. Next slide. So in sample 2 covers the case statement and the do while, which is like the feedback with stimulus and the loop if. So like in the mux, as our case, is if we have 4 cases or 4 selection. And if you relate this to the right-hand side with the Jasmine code, you'll see like there's like 4 label or like 4 pop combination within. And under that, you'll have like 4 label that will execute or assign like each variable under in that block. And lastly, we have like a default, which is like if none of the conditions are true, it will like skip all of these like labels. Then in the feedback, feedback is like do repeat in Pascal, but we want to make it like in C++, like instead of instead of making like until like the expression is true, then we just like take the inverse of that, or like negation, and just like do a plus when like if the expression is true, it's gonna loop back to the feedback, and when it's false, it's gonna exit, just like in C. Next slide. And then this one I mentioned earlier, which is the case statement, which have a series of K branches.
Okay, and now we're gonna show a quick demo of sample program 1. So here's sample program 1. As you can see, we have a module, which is like a function, as well as some statements here, such as store, which is supposed to resemble assembly language. And then we also have some expressions here, which are if less than. So this would be if R2 is less than the float or the number minimum, then this will happen. And this is a similar less than statement. And then we also have our looping statement here. And a unique feature of the looping statement is that you can change like how much the loop is incrementing by each time, which is different from Pascal, where it's always an increment of 1. So now I can, if I just change the arguments to sample program 1, I can compile the D3 file. And you can see that it successfully compiled the program. And now we can create a Jasmine file of and then we can also run our program, which is so as you can see here, it printed that the minimum value is 1.2, which is what was expected from our module, which takes in three values and prints out the minimum. The values passed in were 1.2, 1.3, and 1.5. And we have a printed value of 1.2 right here. And in our loop statement, we're printing from A to Z with an increment of 3. So we print A, then skip over B, C, and print D, and so on after skipping over 2 letters each time. And that's our program, or that's our compiler.
Very good. You're actually generating code that you can execute. Any questions from the audience? Now this language that you're using here with the way you do the arithmetic operators, is that from actual language, or is that something you decided to invent?
Go ahead.
Which part? The add?
Yeah, like the add and so forth.
Yeah, so that's kind of similar to assembly language.
Okay.
The statements are like add, and then you put into registers and a result register.
Because there was a sample program that you showed earlier where you had a number of operations, and so you had to kind of match up the operands with the yeah, right there. That first store where you have idiv, add, and mult. That's almost like prefix notation. So yeah, well, kind of. Yeah, it's different, and I encouraged everybody to do something new and different. So yeah, you definitely came up with the grammar, and your parser handles it, and you generate the right code. So so that's great. Yeah, I'm not sure I would like to write a program with that kind of notation, but you got it to work. Yeah.
Yeah.
So all right, any questions from the audience? Yeah, very good. Very good presentation. You definitely showed off your features, okay? And things were working. All right, so everybody be sure to fill out the survey for this team.
Oh, we just leave it blank for our own team, right?
Oh yeah. Anybody who does a survey for his or her own team, I will ignore the result there. Okay? All right, to the moon.
Perfect. Everyone ready to go?
You're ready to go. Oh,
Okay.
I will then publish your survey, but go ahead.
Okay, perfect. Hi, everyone. We are To the Moon. My name is Reshma, and my teammates are Simmer, Josh, and Kevin. The language we have created is called Moon. Our goal was to create a language that is easy to understand and that users can write code the way they think and avoid all the complicated syntax. Our target audience are beginners who are either just learning how to code or have a little bit of prior coding experience. Ideally, once you learn this language, then it'll be easier for you to learn any other language, as our main focus was to simplify the fundamental elements of coding. This language will be easily picked up by anyone who has a little bit of coding experience, especially in C, as the foundation is correlated to C. Next slide. Let me run through the fundamentals of Moon. The data types we're using are int, string, and real. The basic arithmetic operations that we have used are addition, subtraction, multiplication, and division. The conditional statement we have included is the if statement, and we are using a while loop as one of the looping control statements. The following are the functions with calls and returns that we are used in a code. Lastly, the operator precedence is similar to C, including greater than, greater than equal to, less than equal to, and or. Next slide.
So I'll be covering a little bit of our grammar files. So like Reshma said, we wanted to make all of our statements and everything simplified and easy for beginners to understand, but still kind of follow some convention of other languages like C, so that it kind of bridges the gap between how you would talk versus how you would code. So in the first picture, you can see part of the grammar file for our if statement. And so it's simply if expression, and then following that is a code block that'll have the true statement, and then following that would be the else statement if there is an else statement. And I also have here, you can see the railroad diagram showing the syntax of the if statement. And then you can also see a little bit of our grammar file for the declaration section. And so it follows the convention similar to C or C++ or other languages, where first you say what type the variable is, followed by its name. And so you can have one, as shown in the green text here, integer I or real J. Or if you have multiple, you can separate them with commas like you would in C. Here's more of a grammar file. So as you can see in the first picture, our comparison operators follow a similar format to C, where if you're comparing to see if two numbers are equal, it's two equal signs. And then the not equals use the exclamation mark first, followed by the equal sign. And then you can also see we also have the pretty standard approach for the less than equals, greater than, and greater than equals. Again, because all of these kind of make sense to someone who is not familiar with coding, and they also follow the format of other coding languages. We also created our own loop from statement as an easy intro to the looping mechanic in many programming languages. Compared to the for loop is a little bit confusing for beginners because first you have to initialize a variable, and then you have to say the comparison, and you have to have the increment. Whereas here, our format is loop from, followed by some expression, which could be either a variable or a number or an expression with an operator in it, and then the keyword to, and then another expression. And so this makes things a lot simpler because it's a word syntax that people would understand and remember. And it's flexible because you can have two expressions. Here's a parse tree of the loop from statement I was just talking about. So you can see the example code. In this case, we've used I and 3, so loop from I to 3, and then you have your block of what you want it to do. In this parse tree, I've shown a different example where you use two variables, x and y. So the syntax is loop from x to y, and then do, and then you have some statement, which can be different things inside there. So the point with this is that it can be two variables or numbers, and so it's very easy for beginners to get introduced into using variables in loops, or just how a loop works. And here's a parse tree showing how our declaration section works. So we have a declaration section towards the top of our program, which is indicated by the keyword var. And then we have our different variables declared. So for example, we have the keyword integer followed by I, and we've got a comma to separate it from j, comma k, and then a semicolon. And then we have string z semicolon. So this is following the similar format to languages like C.
And so one of the features that we created was called the assignment statement. And so what the assignment statement does is it sets the left-hand side equal to the right-hand side. And so the left-hand side in this case would be the variable, and then variable identifier, which would be z. And the right-hand side would be the expression, which would be a simple expression, a term, a factor, and the string constant, which would just be a yes. And so in our program, the variables are declared at the beginning of the program, and the values are changed as the main block of the program runs. So on the picture to the right, you can see the variables as the integer I, j, and k. And below, you can see how their values change from I equals to 1, and j equals to 2, and k equals to 2. Next. And then another one of the features that we created was the conditional if type statement. And so the if type statement checks if it's an expression, and then if it's a true expression, it runs, and else if it's a false statement, it runs that. And so it just checks the expression. If it's matched, it returns the true statement, else it returns the false statement. And so on the program to the right, you can see that if I is equal to j, then z would be set to yes, and it would write the line equal, else would be z would be equal to no, and would write the line it would be not equal. And this is just useful for users trying to express a certain case. Next. And one of the other features that we created was called the while loop statement. And so what the while statement does is, so while expression is true, it does the statement. So every iteration it checks an expression, and if the expression is matched, then it does the statement. And so this is useful for users trying to create a loop. Next. And so here we have an example of our Jasmine code. And so on the picture to the left, we have our loop statement, which is printing out testing moon, and if certain should have meant prints out other input. And to our right, we have our if type statement on the top. And so if I is equal to j, then it would print out yes, and else it would print out no. And below on our bottom, we have the assignment statement. And so it checks if both are equal, and if it's not, then it would print out no. Next.
Hi, I'll be covering how our program flows and works. This is just a flow chart to explain how our program will read the lines of code, and just a general way of how you should structure your code if you were to write in our language Moon. So at the top of the program, you would insert the name of the program just to make it easy so you know what you're working with. Underneath that, it's optional, but it's recommended to write some comments about what your code is, what you're trying to do. That way, when other people read the code, they have a bit of understanding of what you were working with. The next block after that would be where you declare your variables. This is very useful because all the variables in the program are declared at the top. So when you're debugging a program, you can see all the types and variables that you're using in the program. So you can change them all in one spot and remove what's needed, what isn't. Then after that, it enters the main block of the program where it actually reads the code and executes statements. So that's in the program body. It'll read the line, execute the statement, and then load the next statement and keep doing that until it sees a closing bracket, which will indicate the end of the program. So next slide. Here we have a simple parse tree for a very simple program. This is basically the hi world of our language. So on the top left, you can see the program is named hi. We have a comment under it just to show how to comment. And then we declare our variable. In this case, it's only one string, which is named x. And then we enter the main block where we set the value of x to the assignment hello world. And then we simply call write x to write out that variable to console. So if this program were to be run, it would just simply execute hello world. It's a very basic program that shows how we use it. And next slide, I'll now be sharing screen for our program in action. So here's a little bit of a larger test program. This one basically just tests our variable declarations, our assignment operators, comparators, and our if statement to make sure that each block works properly. Future edition, we're working on our loop from, but could not get that working. So that'll be in our final submission. So at the top of this program, it's named test. We have a little comment that explains what we're working on, what we need to do. And next we declare our variables. We only have integers and strings in here. And here's our main block of code. We write testing moon. We set the variables to their values. We compare them before here, just printing them out so the user can read them. And then here we test them. We compare I and j. In this case, I is 1, j is 2. So we're hoping to see the no condition where it is false. And down here we compare j to k, which is comparing 2 to 2, which should be true. So we should print out equal, and z should change to yes. And then we have the variables at each test to show how they change. So let's run that. And as you can see, first test here, we compare I to j, which is not true, so we get not equal. And then here we compare j to k, which is true, so we get equal. And since it's true, z is changed to yes, and we can see that the variable changed. So we know that our if statement and comparator statements work as intended. And that's all we have for testing for now.
Now you ran your interpreter there, right? You didn't actually generate code yet.
Oh, not yet.
Okay. Just wanted to make sure. All right, yeah. So you believe this language will help beginning programmers more than learning Pascal or C initially?
Yeah, it's kind of a bridge between the two because Pascal's bit a little harder to learn than C++. So it's a mix of the two, and it's a good foundation for learning other languages.
Okay, yeah, that kind of reminds me of a project that I've had in the past where students, the team tried to compile pseudocode. So they came up with this very, very simplified language that looks very much like, the pseudocode that textbooks use to describe some algorithm. And they actually turned that into a programming language. So I think what you're trying to do is very similar to that. Okay, and any questions from the audience? Any comments? Okay, so be sure to fill out the survey. I think you should all be very proud of yourselves because at the beginning of the semester, I don't think too many of you believe that you can actually write a compiler. And already some of you are already generating code and assembling the code and actually executing programs that you've written in whatever language you chose. And some of you have even gotten creative and invented a language. So that's really cool. You should all be very proud of yourselves. Okay. All right, and any other questions or comments? I think we only have 4 teams today, so I guess we're gonna finish a little bit early. I will talk about the exam, final exam on Thursday, but it ought to be very similar in format to the midterm. I think the midterm had a number of multiple choice questions, and then there were a few short answer type questions. Maybe you didn't think some of the answers were very short, but so essay type questions. It will cover the entire semester with emphasis on the second half, where we really got into compiling and generating Jasmine code. It'll be open book and as before, so you don't have to memorize anything. Just make sure you understand. So maybe on Thursday I'll have a few more words to say about it, but basically it's going to be similar to the midterm. It'll be longer because you'll have more time. And see, the people keep asking when is the final exam, and that is actually in the syllabus. But let me point it out anyway, since we're here. 2 and syllabus. Okay, here we are. Very bottom here. It'll be Monday the 24th, okay, from 2:45 to 5 p.m. So that's what I have here. I am going to update my NASA page. We're making another internship available. So if you are looking for an interesting internship for this summer, I'll have that up posted within the next day or so. Okay. I'm currently talking to the folks at NASA to make sure that they don't go overboard with the requirements. There have been some positions where I have not gotten any resumes because they put so many requirements in there that nobody would qualify for it. So I've been pushing them to loosen up on the requirements, and I assure them that, these are very smart students. If there's something they need to know, they can learn it when they start. And so don't expect the students to know 20 different things. Otherwise, you won't get any resumes. So I will be updating my NASA site. All right, and any other comments or questions? If not, I will have my office hour at 4:30. So I will then sign off. Please remember to fill out the last survey. All right. Okay, I'm signing off. Thank you for coming.
Thank you, Professor.
You're welcome.